In this video, we will learn how to construct a multi-dimensional scaled map using Excel. Now for this exercise, I've just constructed 5 variables by 6, so I've got 30 data points in there. Typically I work in the marketing field, so this would normally be 5 different brands and attributes of those brands. So that's how I would normally look at it. Now the first thing we need to do is get our data into a similar scale. Now I tend to put everything into a 1 to 9 scale. That's because I'm normally working with market research survey information where respondents are asked on a scale of something. The reason I do that is because you could have some large variables. So I've just made up some numbers there that so if I was to put this in a map, these larger numbers would dominate the map and push the attributes around, which is not what I wanted to do. So I've just scaled them back. As you can see, they're pretty straightforward, but there's a formula there. If you want to rescale any number, you take the number, subtract the minimum in its range, in whatever so in this case the minimum here is 100, and then times 8, because 8 plus 1 at the end will get me to 9 as a maximum, and then it's just the range of the data, maximum minus minimum. Okay, so I have scale data. If you want to, you can also play around with the inbuilt functionality of Excel, and we can actually standardize the data using that formula there, and I've calculated the mean and standard deviation. But as I've pointed out, I tend to use this approach. The next thing you need to know is where your data is pointing. And what I mean by that is up here. If I use my data set, if that's a brand and that's an attribute, to what extent do you think the brand has that considered quality or value or something? 9 would mean a very strong fit or match. So therefore it's quite similar. Okay, so what I need to do is convert it. So if you think about it as a map that you would use getting directions for streets and cities, 2 cities that are close together have a small number, and 2 cities far apart have a big number. So all I've done is said, okay, well that's as close as you can get. So I'm reversing that back into a 1. Okay, I'm just using 10 minus whatever that is. So here the 1 would be the furthest away. So I need to make that the biggest number. So this is our second one there. That becomes 9. Okay, so I then have my data in the right sequence. Small meaning close together, larger meaning further apart. Okay, then I've got to basically construct some more data. Now, if I've got direct comparisons between A and W and A and double V all the ways, as you can see, so I've got 30 comparison points. But I don't know the difference between A and B, or A and C, or these variables up here. So how close or how similar are they? So I need to work that out. So we come down here, and what I'm doing is now, these are the letters, the top, this side letters, I'm trying to compare them. And along here is these variables. So how do I do that? How do I compare them? So what I use is this formula here. Okay, so what that is doing is a built-in formula to Excel, so we can type that in. That's the one down the bottom there. Oops, missed it. Do that again. So it sums the squares of the differences in 2 competing ranges. So I just get rid of that. So what this is doing, this is okay, D31, which is here to I31. So it's all of this. So that's 31. So all of that against D32, which is all of that. So it's doing it automatically. And what it's doing is, okay, 1, 5, well that's difference of 4, and I'll square that, it becomes 16. Difference of 4, another 16. Difference of 1 squared is only 1. Again, 4 squared, another 16. And all the way through, okay, gives me that number. I could do that manually. I'll just quickly type that in and come back to the video. Okay, I've just quickly added all that. So here you can see I'm just subtracting those two and then squaring it. And over here the bigger number, the same thing's happening. 8 minus 1.5 squared. And this number here is just the sum of all those. So rather than me doing that manually and copying formulas, I can just do it quickly using that, so it does the whole thing at one time. Okay, so I do that. So what I'm doing is I want to work out how similar these are. So for example, I've highlighted 2 down here. We've got E versus B, and that's the biggest number in this small combination here of 10 comparisons. So that means D and E are least alike. And what I'm doing is how they're answering questions. So if I go through here, well, gee, they're very similar, 5 versus 6. Oh, gee, they're very similar again. Okay, so at this stage, they look very similar. Here, they're very similar. For the first 3 variables, they're quite similar. But then 1, 9, they're opposites. 8, 3, they're almost opposites. And 1, 9, they're almost opposite. They are complete opposites. So for 3 of the variables, they're complete opposites. For 3 of the variables, they're quite similar. But in terms of the comparison, they are the most 2 unlike players together. And then I've got C and E, which is the smallest number. So they're the closest together. So have a look. 6 and 6, the same. 5 and 7, pretty close. 2 and 3, pretty close. 3 and 9, okay, that's different. 5 and 3, 1 and 1. So other than one variable where they do differ, they're quite similar. So now I've got distances here, and I've done the same thing here. I've just used this formula, comparing this and obviously running downwards. And I've used the maximum here. What I've done, if I come over here, I've just put these back into a 1 to 9 scale. So you can see I've just taken the variable, times it by 9, divided by the maximum. So this is just running in a 1 to 9 sort of order. So it's same as here. Okay, so I've got the same sort of scale data. I should point out from time to time, if you're using data that has very similar brands or something is quite similar in this stage, sometimes I actually use a larger multiple than 9 to actually sort of spread the data out a little bit. But I can't tell that until I run the map. So if I find all the brands clustered together and all the variables here being spread out or vice versa, then I know I can just play with that 9 number to make that bigger or smaller to work things out. But in this case, because I've constructed the data, it should be fine. Okay, so I have that. So I have the data initially. I have comparisons between these, and I have comparisons here. And I can just put this all together. I've just put it in my distance table. There are gaps because there are duplicates. So this is my initial data. This is A's versus the first 5 letters, and this is the end of the alphabet. So this is just coming straight down, as you can see. Okay, so the reason there's no UU, because they're the same variable, so that would be 0 if I put it in, so all these would be 0. And the reason there is no AB here is because I have it here. So there's no point. I could put it in twice. It wouldn't matter, but just to make sure you've got your data. And as you can see, just off 5 and 6 attributes, I have about 55 data points sitting there. So this tells me for each one, for A, for example, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 comparison points. Because I've got 5 here, 6 here, that's 11. So each thing should have, each variable you're using should have obviously a distance away from each variable. Okay, so this is my key data points that I'm going to play with. Then I'm going to try and replicate this in a map, and I've been playing with it, but basically what we need to do is come up with some sort of starting point. And the typical approach is what I've done here. I've taken, I'll get back to A, but B, I've taken 6 and 0. C, I've taken 0 and 3. What I'm doing is doing them relative to A. Okay, so what I'm doing here, as you can see, we are 671, 301, 746. So if I come down here, I'm just using those numbers and alternating between X and Y, 0, 0, 0, etc. Okay, so that's their relativeness to A. And as we come back up here, we've got 183, 183. So that's all I'm doing. It's just to spread out, and you should have a starting point like this. So these are the variables. You can see that's 3.1, so that's C sitting there already. And they're spread out to some degree before I even try to replicate a map. I could either put A over here as 00, or I typically tend to put it in the middle of the map to try and get some diversity. Okay, I've already run this data, but we'll get to that in a second. Okay, so I haven't run it yet, but it's on another spreadsheet. What I'm trying to do now is I've got a start map, and I've got a distance map here. What this is doing is coming off here and replicating. So you see the same design is off my actual data that I'm trying to replicate. Down here, what I'm doing is I'm using that same formula where I am comparing. So this is A versus W. So as you can come up G71. So I'm using that against, this one, that. So if I bring that up as a formula, you can see it's summing the squares. So 4 minus 1, which would be 3, squared, which would give me 9. 4 minus 0 would give me another 16 squared to 25. So it's showing me the difference using the same formula as I did before. What I want to do is align. So this is what this is doing, is reflecting the distances on the actual map. Okay, so A is obviously over here and U is here. So it's saying, okay, using that method, what is the distance between those 2 points? Okay. We know what it is in real life. Now we're putting it on a map. Okay. Now what I want to do is minimize this. I want this to be as close to that as possible. Real data, measurements from the map. Okay. So basically, if my map was perfect, which it couldn't be, it would replicate those numbers. So what I'm doing is down here, I go, okay, I've taken D55, which is that number there, of the real data. What is it here? So that's D85. I'm just squaring it, squaring the difference and taking a square root of the difference. Okay, so I want that to be obviously the same number. I want these to be as low as possible. Okay, so if that was only 1, if that was mapped accurately and W was right up here next to it, then I would basically have a match, which is my goal. Okay, so that's the starting point. What we're trying to do is match the data. So this here measures the map and we want that to be the same as the real data. Okay, I've just run it, but I'll show you how you do it. You go up to data, you go across, so it's not showing me, but right on the edge outside the screen, over there is solver. I'm just bringing you back. So click on the solver button. It'll bring up this dialog box. So basically what I'm saying is I want this cell here, E113, I want it to be minimized. I want my difference between the two data sets to be small as possible. I'm doing it by changing the map points. Okay, I'll get back to that in a second, show you what they are. Well, I can just click on actually. So those points there, okay, my actual map. I want you to change those points, okay, keeping them in a scale of 1 to 10 or 0 to 10. I've ticked that box and I'm going to use evolutionary. Okay, so what, I'll come back to running it, but what that's doing is it's going to change these numbers. Okay, I've already run it, that's what we started with. It changes that in order to change, move the map around. I'll show you that in a second. Does that to change these numbers and with the goal of minimizing that. So if I just click solver and solve it, you'll see what happens. Pops up down the bottom is, I've already got it down to 43 because I've just run it, but it obviously started a lot higher. And what happens, it just goes through a whole series of, as it says, trial solutions, moving it around a little bit to see what would happen, trying to get that 43 down as low as possible. So I'll just pause while it keeps running. It runs about 1 or 2 minutes. Okay, when it finishes, it'll come up and says, hey, we can't improve it. We've done as best we could. And we just click OK. And where we started with these, and we end up with these. That's not the actual map. And as you can see, the differences, they're quite minimal. We've got the odd one that's not a great fit, but the rest of them have been brought down fairly close. So let's have a look at that's our starting point, but I've got my new map over here. Okay, I'm just going to bring that down. Oopsie. Okay, what I want to show you is this is the final map. This is the data we started with, and I've color-coded it for a couple of reasons. Okay, as you can see, I brought it into 3 to 7 because it was a little bit clustered towards the middle. So we have something like, this is a check for us. So A and W and double Y, that A should be closest to those, so I've highlighted those. So we've got A, yep, it's close to those, that makes sense. And it should be fair away from double V, which is not a close match, so it's on the other side of the map, so that makes sense. B should be close to double X, yep, that's good. C and double Z, ooh, okay, that's a bit funny, that's not ideal, so, but it's, okay, so we'll come back to that as an alternative. D and double V, at the top here, that makes sense, and it should be away from double X, yep, should be away from W, yep, that'll make sense, and then E should be close to double Z, yep, and a long way from double X. So generally it makes sense. I've put W in the middle here. As you can see, it's fairly close to everybody. So what will happen is that rather than sitting with anybody, it sits in the middle as it's some sort of tug-of-war type situation. So there's D, B, C, A. They're all fighting to get as close as possible to W. But because it's not directly owned by any of the brands, it sort of sits off by itself. Now I'm going to show you another approach of doing this. So I've just clicked across somewhere. The same thing applies. Okay, same data, all that sort of thing. But what I'm doing here is a different calculation method. What I do is I have my map distance and my actual distance, okay, from my survey data that I constructed before, and my map information. But what I do now is I rank them. So I'm just going rank here, and I've ranked these things from closest to furthest away. So that's obviously close, and I'll pick this one down here, furthest. So if I come back to my rankings, that's number 1, and that's number 52 on the list. And I do the same thing here, the stuff that's coming off the map onto here, and I rank those. Okay, so my goal when I do Solver this time, I should bring up Solver. What I'm doing is trying to, and I've got a name for these two data ranks. What I'm trying to do is maximize the correlations between the two rankings. Now I've just called this calc map, but we'll have a look. So again, I want to change the mapping points, and what I'm trying to do, again, clicking those two things again. In this task, I'm trying to maximize the correlation between the rankings. Now I've run this already, but again, you can see down the bottom, so I'll just pause. Okay, it's come back with a slight improvement. Okay, that's good to keep in mind. First time I ran this, it was about 91%, so it's improved a little bit. Like I said, this comes back to the start point. So when I reran this, it was starting from a different set. It picked up these as the start points and then improved, but we've got a very strong correlation between this rankings, the data rankings, and the actual map rankings. So you can see they're fairly similar. You know, they're not perfect, but they're pretty close. Okay, now we'll go across to put the map up here. Okay, so I'll just bring that down in size again so we can do the same exercise as before. Okay, so again, we've got W in the middle, okay, and everything's sort of revolving around that because that's a shared attribute that everybody seems to own. If we reality check, A should be there, make between those two, that makes sense, a long way from V, yep, that makes sense. B should be with double X, yep, and a long way from Z, yep, that makes sense. C should be near double Z, that makes sense. D should be double V, yep, that's good. Away from W and away from double X, yep, that's good. And E and Z, yep, that makes sense, and away from double X. So in reality, this is somewhat of a little bit of a better map. So let's just compare the two. I'll just move it around for you. Okay, I've just put the two maps side by side, and first thing you can see is they look quite different, but that's just the orientation. So I'm going to, it's a little bit harder to read, but I'm just going to switch this around. Oops. And then just sort of square it up so it looks a bit similar. Okay, it's not ideal. Okay, but you can see the overall similarities. We've got B and X over here. We've got U, A, Y running up to Z, E and C, D and W. So double V, sorry. So other than that, it's pretty well the right map. It's the same map, it's just a different way of calculating it. Now what this opportunity will give you is a slightly different variation. Okay, so my concern here on this map was C versus Z, and it just seemed to be too far away, and it was a little bit too close for A. Okay, they are somewhat related. So yeah, this makes a fair bit of sense, but this one's probably a slightly better map from a logic perspective because we can see C and Z are closer and A and C are a little bit more spread apart. But as I showed you, essentially, they're almost an identical map, just a different way of doing it. What I would suggest is that you possibly use both. If you have a lot more complicated data, so this is fairly simple, each time you run these maps you could get a different looking map. Now it could be just orientation, so it's spinning it around, or it could be the way Excel approaches it is almost on a trial and error basis. So it might go, okay, different starting point, and just end up in a somewhat different perspective. Okay, so you've got to think of why am I using this? If it's an analytical approach, then multiple maps where the data is presented in different ways might be very helpful for your analysis. Now keep in mind that there's no solutions to these. As I pointed out before, A is mapping against 9 variables. What's its distance from each of those? So there's no solution on a two-dimensional map of a multi-dimensional data set. So from an analytical viewpoint, you pick several maps of difference, and you go, okay, why is that happening? Well, is C and A, are they, in marketing terms, are they direct competitors, etc.? But in terms of a communication, something going into a report, you would pick the one that makes most sense. So I would pick the second one in this case. That just happened by chance, but in some occasions this approach, both approaches are valid, but they'll provide slightly different maps. Okay, so hopefully that helps, and obviously there's links in the video to the website on perceptual maps.